Welcome again to this fifth webinar of the GI WACAF webinar series. We will be talking about shoreline response techniques today. Let me first introduce you the GI WACAF project, so the Global Initiative for West Central and Southern Africa. It's a project that was put forth by the IMO and ITOPF. So the IMO is in the International Maritime Organization, the United Nations specialized agency that is responsible for navigation safety and the protection of the marine environment. And ITOPF is the association of actors of the oil and gas industry to promote environmental and social performance. So the objective of the GI WACAF project is really to enhance the capacity of the 22 partner countries, which you can see on the map, to prepare for and respond to oil spills, so that it can better protect their marine and coastal environment and communities. To do so, we organize a couple of activities, for example, national or sub-regional workshops. We also organize trainings, exercises, conferences, and technical assistance activities. So really, briefly, the GI WACAF project is a joint endeavor of the public and private sectors to manage oil spill risk and mitigate associated impacts. The project supports 22 African partner countries in the development and implementation of sub-regional and national oil spill preparedness and response systems. The project maintains a constant liaison with partner countries and the industry to provide tailored capacity building solutions. We, as I said before, to do so, we organize workshops, training, courses, and exercises. We encourage better communications and collaboration between governments and industry. And finally, we encourage partner countries to ratify and implement international conventions from IMO and other UN bodies, which was the topic of one of our previous webinars. To have more information regarding the GI WACAF project, you can follow us on LinkedIn, and you can also go on our website. About the GI WACAF webinar series. So this is a series of webinars covering the various dimensions of oil spill preparedness and response. We are currently delivering the fifth webinar today, which will be the last for this year. So today we'll be talking about shoreline response techniques, with the objective of gaining an understanding of the available response techniques during the no spill when reaching the shore, understand their key strengths and limits, and also gain knowledge of the available decision-making tools when choosing between the these different shoreline response techniques. So we have this tool named SCAT, which will be presented after. And finally, you will have the opportunity to really gain knowledge on the challenges and successes faced when responding to an oil pollution, with all the experience shared by our experts. So today, as I was introducing them earlier, we have a first presentation by Stéphane Grenon regarding SCAT. Then we'll have another presentation by Ken Church regarding shoreline response techniques. And then we'll have Dr. Annabelle Nicolas-Kopek ending this webinar with the presentation, which will be actually a case study. Thank you very much. And I now give the floor to Stéphane for the first presentation.
Thank you, Chloe. Good afternoon, everybody. I'm very happy to be with you this afternoon to talk to you about the SCAT, the Shoreline Cleanup Assessment Technique. And my objective this afternoon, I have about 20 minutes, so it's to give you an overview of what SCAT is and how it can be used to support decision-making during a response, mainly involving shoreline cleanup. That's what we're going to try to do. Just a few words about myself. Chloe introduced me, Stéphane Grenon. I'm the managing director with a company called TRIOX Environmental Emergencies, consulting firm offering services in preparedness and response. I have about 25 years of experience in oil, chemical, and spill response. And we have some people in the UK, Canada, and Singapore. And if you want to know more, there's a website that you can go visit. Okay, so going back to the main topic for today, let's pretend for a minute that you are facing a situation such as this one. We have oil on the water going towards the shoreline, hitting the shoreline. And when we do look at the shoreline, we see that we have many different types and different environments that are potentially impacted by oil. I mean, we have an urban area, we have a port, we have vegetation, we have rivers, very many different potentially impacted sites with different sensitivities. And one of the questions we have when we begin the response is where do we need to start responding and what should be our priorities? And in terms of cleanup assessment, it's what kind of technique we should be using to make sure that we protect the environment, that we don't cause additional damages. And basically, this is what SCAT, the Shoreline Cleanup Assessment Technique, will help you to achieve. It's really a decision-making tool that is there to support the operation throughout the response. So it's something we use at the beginning, and it keeps going on as long as the shoreline cleanup is completed. And you have to see this methodology as really as an operational tool, providing information to the operation groups to be able to manage cleanup and to do it properly. It is not a technique that we use to document potential claims or environmental impact. It's not an impact assessment, so it's an operational tool. And that's a really key information you need to remember today. Why do we need it? I mean, like I just showed you on the picture, we have a situation where we have many questions. The first one being what kind of shoreline, what kind of substrate is impacted by the oil. You'll see later this is a key information when deciding on the shoreline cleanup techniques. We need to describe the oiling. We need to describe where is the oil. Is it in the upper beach, in the swash area, intertidal zone? Is it subsurface? So we need to document that information. How much oil is there? How is it spread out on the shoreline? What's the thickness of it? So we can estimate volume and level of effort and estimate the resources that might be needed to remove this oil. And also quite a fundamental question. I mean, do we need to clean it based on the environment we are in? If there is wave energy and the type of contamination, do we need to send people out there and recover the oil, or nature will take care of itself and degrade that oil? So that's a key question we need to answer. How we need to clean it, how much we need to clean, and one key information is how are we going to decide when the cleanup is over. So the SCAT methodology will help you to gather information from the field to answer all of these questions and to support your decision-making process during the shoreline cleanup phases. Before I go into more details about the information we're collecting, what is important to know is that SCAT is an internationally recognized technique. It's been adopted by multiple countries and organizations around the world. Here I put 5 examples of SCAT manuals that are around that you can have a look and learn more about the technique. SCAT started pretty much during the Exxon Valdez incident in 1989 and has been evolving since that time and to reach the technique that we know now, and that is pretty much widely adopted worldwide. Okay, so during the SCAT process, basically, we carry out shoreline surveys. So we're going to send people out to in the field to collect key information. And the information that we're collecting is about the shoreline type, the oiling condition. So we need to know, you'll see with the next presentation, I mean, we don't clean a sandy beach the same way we do clean a marsh area, for example, or boulders or that type of environment. So this is the first key element we need to collect. The oiling conditions, is the oil fresh? Is it mixed with sand? Is it very viscous? Is it emulsified? These are all important questions we need to answer. So our teams in the field will collect that information. And while they're out there in the field, they will also look at environmental constraints that could complicate shoreline cleanup operation. So we'll look at access, we'll look at sensitivities on the beaches, on the shoreline, and also is there any cultural sites, such as archaeological sites or religious sites that are directly on the shoreline or in proximity to where our cleanup shoreline might take place. And this is important to document and to make sure that we don't create damages by sending teams into those sensitive environments. The next thing that we'll be able to do with SCAT is to identify what are the best shoreline techniques that we can use to clean that beach based on the information. And what we're aiming to do is really to select a shoreline cleanup technique that will bring net environmental benefit, which is protecting the environment and not causing additional damage to the environment because we are cleaning the beach. So this is really a key element. I mean, yes, there might be oil on the beach, and yes, we have techniques to remove it, but we want to select the proper technique so we don't create more damage, long-lasting damages. So we have to be to recognize that, and SCAT will help you make that type of decision. The information will also help to develop shoreline cleanup endpoints, so criteria when we reach these criteria, we will stop cleaning the shoreline. And that's based on the sensitivity of the shoreline, the oiling type, and so on. So these criteria are a key element in the response. And SCAT as well will be going on throughout the response usually. I mean, it's at the beginning, it's during the cleanup operation, and it's also at the end. And because that people are visiting the sites at numerous times, they can monitor the progress of the cleanup crews. The methodology rests on 5 key principles. They're very simple. The first one, which is quite important, is SCAT provides a systematic way of assessing the shoreline contamination in affected area. So it's that systematic approach that will bring a huge benefit to the decision maker during a response. Also, during a SCAT, we will segment the shoreline, usually based on shoreline types and substrate, to facilitate the organization of the field activities of the shoreline operation, and also to identify shoreline cleanup techniques that are appropriate for very specific segments. So each segment will have a specific technique or a set of techniques, of cleanup techniques, as identified by the SCAT teams and the operation group. Another very interesting aspect is the standard terminology that we are using when we do SCAT. So everybody speaks the same language, everybody uses the same terminology, for example, to describe oil. For some people, fresh oil might be different. So with SCAT, we have clear definition, and when we use a term, everybody understands and knows about it. And that's valid for people doing SCAT, but also for the operation group and the people doing cleanup. And it's a great tool to manage the operations and to support the decision making. And one of the key principles is the SCAT team is based on a concept of having interagency people within the team. So we are all working together, looking at the shoreline at the same time and describing the shoreline, the contamination, and so on together as a group. So this technique brings the responsible party, usually if it's a ship, will be someone designated by the ship owner as an expert, a specialist. Government agencies will participate, local people, it could be people living in a specific village, or land users will be involved in the teams to make and to describe the environment and the contamination all together, and that saves a lot of problems further on, because people are seeing and agreeing in the field about what is the situation. Okay, so looking more at the information we're going to collect, I'll show you some examples of what we are collecting and how, and looking at the terminology that SCAT uses. So, as I said, the shoreline types, key information that we will be collecting, shoreline oiling, and the environment, and I'll show you how we are doing this during SCAT using that methodology. Obviously, the first one is the shoreline types, so that's pretty basic. It's a key element, as I said, in selecting your cleanup technique. Ken will talk about that after, but the proper identification of the shoreline type will guide those decisions about how we're going to clean, and it's informed the process based on the sensitivity of the shoreline types. I'm not going into details about all the shoreline types there are out there. I'm not talking about the environmental sensitivity index methodology, but if you have done your homework very well and you have a good emergency plan, I mean, you should have maps such as this one, which this one is a sensitivity map. Basically, what we're looking at here is a ESI classification, environmental sensitivity index, for the shoreline. So each coastal line, you see different colors. You see purple, blue, and green. All of these lines represent a particular shoreline type. So everything is identified in advance. So you know that you don't even have to go in the field. It's all been done before. And you see those perpendicular lines to the coast there. These represent shore segment boundaries. So we have pre-segmented the shoreline into small chunk based on the shoreline type, access sometime, and all of these segments have a name which is specific, which will be used by operation as well, so people will know exactly, will use the same language during the response, and they will know the specific location, what do they correspond to. So usually that type of exercise, we do it in advance when we do our emergency plan, but if it's not done, it's something that can be done in the field at the beginning of the incident. It is one of the first information we will collect. The other information we collect in the field is where is the oil on the shoreline. So we're interested to know if it's surface oil. We're interested to know if it's in the upper beach, it's in the back shore, is it in the intertidal area, and also we're interested to know if there is a subsurface oiling, so oil that's been buried because of energy and of the shoreline energy. We see that quite often with sandy beaches. So we need to look for that as well, and the SCAT methodology will enable us to describe the position of that oil on the shoreline. For oil that might be submerged or sunken, typically SCAT is not designed specifically for that, but you can easily adapt the concept and to use that, the SCAT approach to detect sunken oil and submerged oil in the near shore environment, okay, to document that, but that's another topic. The other information we're collecting in the field is oil distribution and thickness. So oil distribution, it's very rare, I would say. I mean, it's unusual that we have an homogeneous contamination on the shoreline. I mean, it's going to be usually spots here and there. So with the SCAT approach, we have what you're seeing on the left of the slide there. I mean, you're seeing a distribution schematic. So people in the field will use that to describe, is it 12% coverage, 50, 90% coverage on the shoreline. So that provides information about the potential volume of oil that needs to be recovered. And the other element to this is the oil thickness. which will help us evaluate the volume as well. But what is interesting here in the table that you have on the right, it's an example of what I was saying, the terminology, the standard terminology that is used during SCAT. I mean, you see there you have TO, CV, CT, ST, which all of these are codes that refer to specific oil thickness. CV is cover, and cover for someone that's trained in SCAT means you know that you have oil thickness above 0.1 centimeter, between 0.1 and 1 centimeter. So it gives you a good idea of what the thickness of oil is on the shoreline. And you'll see in the next presentation that you can adapt your shoreline cleanup technique based on that information. Another key element that we are collecting is the oil character. So how does the oil look like in the field? So is it fresh? Is it still pretty fluid and easily pumpable, for example, or is it emulsified and quite viscous and so on? So the SCAT methodology will help us describe the character of the oil on the shoreline. And again, this information will be very important when it's going to be time to look at the potential technique. The same thing for subsurface oiling. As I said, we can have buried oil on the shoreline. So again, with the SCAT methodology, we have a standard terminology to describe oil in the sediment subsurface. Is it partially filled pores and so on? So everything has set definition. And when we when we are in a response where we are doing SCAT, you get into a mode where people use that terminology and you know exactly what they're talking about because we're all sharing the same language. So this is quite a useful element of SCAT, not only to identify and to characterize the oiling, but also in your discussion with the operation group that will be carry out the cleanup. So that's something very interesting. All of the information, I just gave you a very quick overview. Of course, we can spend 4 or 5 days doing a SCAT training, but all of that information we collect in the field, we usually report it on the SCAT forms, and there's various SCAT forms for different environments, but I'm not going to go into the details here. So again, it's a systematic approach, so everything is kind of already set for you. The way to present the information is pre-established. Before, we used to do these forms, filling them by hand and with a pencil and so on. But right now, we have a lot of tools that we can use in the field, electronic data collection tools that will geo-reference all the information and the photographs and so on. So that's kind of the process now for data collection in the field is quite streamlined nowadays, and it's only getting better and better. So now the next part of the presentation, I mean, I showed you the information that SCAT is mainly used to collect, and now I will show you there's different phases when we're going into a SCAT program that we maintain throughout the response, and we're just gonna show you some example of what these phases are. One key element before we look at phases is the SCAT team. Like I said, interagency, so different people with different background looking at contamination. Usually we have small teams. We don't want to be 15 people in a team. I mean, it's not an expedition. It's a team that needs to work on a very specific aspect of response. So usually 2, 3, maybe 4 people will be in the team under the supervision of a SCAT team lead, which is usually someone that's going to be hired by the responsible party, either a ship or another offshore facility. Will be someone that is quite familiar with the information on the shoreline morphology and the different dynamics in the coastal dynamics, and about oiling as well. And then we will add a representative from the place where we are, so a local government representative, people from landowners or users of the coast will participate as well. And we look together, as I said, at the contamination, and we report it all together trying to reach a consensus in the field about what we are seeing and what is the level of contamination using that standard methodology and terminology that I just showed you. Of course, these people, they need some basic equipment. The information needs to be geo-referenced, and we take a lot of photos and so on and describe the environment. Health and safety is paramount. I mean, safety of responders is always a key element, so you need to think about that and take care about that. And also there's a logistic that comes with deploying SCAT teams in the field, making sure you can transport them and they have everything they need while they're in the field. And depending on access, I mean, it could be done by road, could be done by boat, and it could be done by helicopter as well, dropping people on the shoreline, depending on the situation. So if we go back to phases, I mean, when we have an incident, if you go back to the first slide I showed you with a picture where we had oil going all over the place and impacting different areas, basically the first thing we would do is look at the coast using probably an helicopter or a boat, depending on the scale and what's the situation. And the idea here is really to gather information very rapidly about what's the scope of the problem, how big is the incident, and also what is the oiling of the shoreline, how much oil is reaching the shoreline. And really the objective there is to give a quick turnaround of information to the responders that will be doing the cleanup. So usually when we do the first overflight like this, we look at areas where we have fresh oil that could remobilize with the next tide, for example, where we can send teams quickly to recover before that happened. Okay, but just scaling the problem, and if we can do a video as well, that's always useful because you have video documentation of what the status of the shoreline was. And it's a good practice to do if it's possible. And then in the second phase, which is pretty much the whole duration of the response, we will have people in the ground, in the field, collecting data, either walking, either driving on the beach, or using boats, and so on. So it's a really detailed look at the contamination and collecting the information that I just previously shown, filling the forms or filling your electronic data collection tool. Usually for most incident, we don't need a lot of teams, 2, 3, 4, 5 teams for kind of a significant incident. If we look at the other extreme, the Deepwater Horizon, we were about like 15, 17 teams, but we had about a long stretch of coast to cover. That's a bit extreme, but in most cases, I mean, 2, 3 teams will do the job. And the teams are usually sent in advance of operation, so they will go inspect beaches before operation will show up to clean. So we just need to, you get into a groove, usually you stay 2, 3 days in advance of the operation group, and you feed the information back so they can adjust their cleaning techniques. Once the shoreline cleanup is completed, usually in a formal SCAT program, I would say, I mean, the teams, they go back and they go and see if the cleanup met the objective, if the end-up criteria have been reached, and they can recommend no more action or further action. And you can use the same process to do some monitoring of special areas or different kinds of inspection. Okay, so very rapidly, I mean, this is quite a quick overview of what SCAT is. I lost the slide, but basically without SCAT, there will be a lot of decisions that would be taken at the last minute in the field. We would not have all of the relevant information to make decision, and that's quite a key element. And just to conclude, I think what's really important is to remember that this is a SCAT provides a systematic approach to collect that very valuable information to feed the operation group, so people doing the actual cleanup. I think that's the key element. People often see SCAT as that's a process that could be heavy to manage with lots of data, but you have to remember this is key information that the shoreline cleanup teams will require, and it's really you have to keep it. The focus of the SCAT team needs to be focused on collection of operational data. Okay, so that completes my presentation. I think we'll come back later with some. I think we have 2 polls actually.
Thank you very much, Stefan. So I was going to broadcast the first question that you have for the audience, which is the following. So normally you can answer this question. I'll give you 50 seconds. So the question is the following. Have you ever conducted a shoreline contamination assessment during an oil spill?
So I can see that most people have not done a shoreline assessment, so that's good in a sense. I mean, if you have to develop plans for that task, I mean, I strongly recommend that you look at the different SCAT manuals to prepare and make sure you have all the elements.
All right, thank you. Then moving on to the next poll. The question is the following. Do you see the sector's prioritization as a difficulty during an oil spill?
Right, that's pretty even, so that's good. I mean, that's that's one of the key aspects of emergency response anyway. It's to be able to prioritize action and make decision, and to be able to do so, I mean, it's good to have the relevant information to do that. So prioritization sometimes can be a challenge if you don't have the information.
All right.
Thank you.
Thank you very much, Stefan. Well, it is now time for Ken Church to present the various shoreline cleaning techniques. So, Ken, I'll let you set up your presentation. While doing so, let me remind you that all the webinar material, including presentations and other related documents, are currently available for download below the chat box.
Hi there, sorry, I'm just trying to get my presentation.
No problem, I'll do it for you.
Thank you very much.
Here you go.
Okay, thank you. So, my name's Ken Church. I work for Oil Spill Response. I'm based in the UK. I've been with Oil Spill Response for around about 12 years now. Attended various spills at places around the world, both on the shoreline and offshore. Today I'm going to I'm going to provide an overview of shoreline cleanup. As you can imagine, shoreline cleanup is a vast subject, and I won't be able to cover every aspect in the next sort of half an hour, but I will briefly discuss different shoreline types, and then some of the response techniques that we may use on various shoreline types. As you can imagine, there are lots of different shoreline types, and those differing environmental conditions will lead to differing species, which leads to different levels of sensitivity. And being aware of those levels of sensitivity when we're responding to a shoreline is quite important. Different shoreline types will also require different cleanup techniques. We can't use the same technique across all shoreline types, as I'm sure you can imagine. So I'm going to start with the poll quite early on. I want to ask if you could tell me which of the following shoreline types is the most sensitive to oil spills. Which of those shoreline types you can see on the screen there do you think would be the most environmentally sensitive to oil spills?
Ken, let's give again 20 seconds more for the attendees to answer. I'll let you know when it's done.
Mm-hmm.
All right, I'm closing the poll right now.
Excellent. I'm glad to see that most of you got that right. It is indeed mangroves. Stefan briefly mentioned the environmental sensitivity index on the previous presentation. I'm going to give you an example of that in a minute. But on that environmental sensitivity index, mangroves are the most environmentally sensitive shoreline to oil spills. They're at one end of that scale. At the other end of the scale are exposed rocky shores, which are the least environmentally sensitive to oil spills. That doesn't mean they have no sensitivities. There are certain things that live in rocky shorelines that are sensitive to oil spills, but on the whole, they are less environmentally sensitive. because an exposed rocky shore is something that is what we call a high energy environment. Lots of wave action and tidal action. Therefore, anything that does live there, any creatures, organisms, species that live there are generally quite resilient, and that includes oil spills. On the other extreme, less energy, some tidal action, but not much, are mangroves, and they're more environmentally sensitive. They're nursery sites for fish, nesting sites for birds, and the such like. And the other shoreline types are all on that scale, which I will share with you now. So that's the environmental sensitivity index. There are lots of different shoreline types, as you can see, all rated from 1 to 10, 1 being the least environmentally sensitive and 10 being the most environmentally sensitive. So knowing what type of shoreline we're dealing with before we start responding to that shoreline is quite important, as you can see. And that's one of the things that, as Stefan's mentioned, the SCAT team will be looking at the different shoreline types and the type of oiling that's on that shoreline type, which will lead us to produce a shoreline treatment recommendation for that particular shoreline type, which then sets the end point of how what we're going to clean up to on that shoreline. So rocky shoreline, we mentioned already, that can be split into different zones depending on the tidal action, things like that, but generally pretty resilient to oil spills. Different species can tolerate different exposure levels there. As I said, high energy areas, so generally quite resilient to oil spills. Sandy beaches, they're on that scale, but there's a couple of different types of sandy beach based on their grain size, so either a 3/8 or a 4 on the ESI. But there are things that live on sandy beaches, and they are feeding zones for birds and mammals as well. So they have some environmental sensitivity. It's not just about the environment as well; it's about the oil type. So when the oil impacts the shoreline, the type of oil and the amount of oil will indicate how far it's going to penetrate into a shoreline, particularly on a sandy beach or a gravel beach potentially. The finer, the lighter the oil, the more filtering you're going to get into the sediment. Basically, the thicker, heavier oils are more likely to sit on the top. The finer, thinner oils are likely to penetrate further into the sediment. Tidal flats, they're quite high in that environmental sensitivity. There are 9A and 9C for a couple of different tidal flats there. There are also exposed tidal flats, which I think are a 7. Again, you can imagine bird feeding areas, nursery grounds for fish, so quite environmentally sensitive, and quite often are placed alongside other environmentally sensitive areas like mangroves, so quite high up on the scale there. And then right at the very top of the scale is the mangrove itself, as I already mentioned, very environmentally sensitive, difficult to clean, as we'll talk about a little bit later on. Habitat for nurseries for fishing, nesting sites for birds. Mangroves breathe through their roots, and that's the part that gets oiled. When oil does come into mangrove, that's where the oil will deposit itself around their roots, so they breathe through their roots. So you can imagine that an oil spill in a mangrove can cause quite a lot of long-term damage. So one of the things that the SCAT team will be doing, as Stefan mentioned, they'll be carrying out these surveys, looking at different shoreline types. And by taking the information that SCAT team provide, you can then prioritise your sites. You might prioritise your sites, some of them for protection. The chances are that you've got a reasonable size spill, you won't be able to protect your entire shoreline. But by knowing the different types of shoreline, the different sensitivities, whether they be environmental or socioeconomic, you can then start thinking about prioritising areas for protection to maybe prevent the oil from getting there. But in some cases, you won't be able to do that. You will actually get oil on the shoreline. And at that point, there will be is when you need to think about how you're going to clean up that shoreline type. So what are the goals of a shoreline cleanup response? You might think that the goal is to bring the shoreline back to the state it was before the oil arrived. That's not necessarily always the case, and quite often, in fact, that's not the case. Sometimes it is. So if you've got a particular shoreline type that we can clean back to that standard, then that's great. But quite often we won't be able to do that. But what we are trying to achieve is accelerate that natural recovery. So one of the things that SCAT team survey is going to be looking at is the oiling level, the environmental background, and they're also going to produce a shoreline treatment recommendation. And on that shoreline treatment recommendation, there will be an end point. And the end point is the point at which you stop cleaning to allow nature to take over and basically finish off the job. Because if we were to carry on cleaning at that point, we're probably going to cause more long-term damage than we would if you let nature take over and finish off. So in many cases, that means we won't clean the shoreline back to the original condition it was before the oil got there, because it's difficult to do so, and we would cause that more long-term damage. So what we're trying to achieve is accelerate natural recovery and minimise the impact of our cleanup operations. I'll give you some examples of that as we go through this further through this presentation. So shoreline treatment. So we've had an oil spill at sea. It's heading towards our shoreline. Before the oil gets to the shoreline, if we have the time and the resources, some basic things that we can do to make lives easier for ourselves and to minimise that environmental and shoreline impact. If we've got a shoreline like this, we get our survey teams come across a shoreline like this. It's got lots of debris on it, or even just lots of seaweed, things like that on the shoreline. One of the things that we can do to minimise the impact is to get there and do a pre-beach clean, a pre-shoreline clean. That removes all that debris, stops it getting oiled when the oil does arrive, and means we've got less waste to deal with. I'll mention waste again later on, but waste can be a massive subject through a shoreline response. So something needs to be thought about early. If we can minimise that waste impact, then that makes life easier for us further down the line. So removing any of that oil debris, any of that debris that could get oiled, or seaweed, putting it either above the high water line or removing it completely if that's suitable for disposal, then that makes it easier to respond to that shoreline when the oil does arrive. When the oil arrives on the sandy shoreline, we've got certain things we can do to clean it up. There are 3 stages to a shoreline response. Stage 1, gross contamination removal. Stage 2, removal of moderate to heavy contamination, and then stage 3, final treatment. That's getting to our end point, basically, the point at which we're going to step away from the shoreline. So that's stage 1, gross contamination removal. What we're going to do here is, Stefan mentioned about getting there and removing any mobile oil, basically any oil that is still mobile and may remobilize and contaminate another section of shoreline somewhere else. During the stage 1, we're trying to stop that from remobilizing and removing that from the shoreline. So this is, on the overall response side of things, this is probably one of the shorter sort of stages. We're going to get in there, any oil that's either deposited at high tide and then potentially remobilize the next high tide. We're trying to get in there and remove that so it doesn't get picked up and moved and contaminate somewhere else. So that's any loose oil, basically, or any oil debris as well. How do we do that? We can use booms and skimmers. I think many of you will have hopefully viewed the offshore containment, the offshore response webinar earlier in this series. And we use booms and skimmers offshore. We can also use booms and skimmers on the shoreline to contain the oil in a certain area so it can't remobilize using the booms. And then we use a skimmer, which is basically a floating pump. We put that into that oily water and then we remove the oil from the surface. So that's one way of doing that. We can use mechanical recovery in some cases, as long as we get access with suitable machinery and that is deemed a suitable response, then we could use mechanical recovery. But more often than not, we'll end up with using manual recovery. And we use manual recovery across all 3 of the stages, really. And in most cases, manual recovery is what we'll have to use for many reasons: access, availability of equipment, things like that. So manual recovery is quite often what we'll resort to for that stage 1 and the other stages as well. So some of the advantages of booms and skimmers: reduction in waste, because the skimmers will remove oil, a high oil to water ratio, so you don't have a lot of other waste, as much other waste to deal with. So you get a high proportion of oil to water. A relatively small workforce is required, but they do need to be trained responders who can operate the machinery. So you need specialist equipment. So that's not always something that's to hand, if you like, at the time of response. That can take time to mobilize to an area. It does prevent the oil from migrating to additional shoreline areas of the shoreline, which is what we're trying to do, is trying to stop the oil from remobilizing. But it is limited by the weather as well. Putting booms out is great in calm conditions and will work very well. But if there's any sort of wave action or exposed shoreline, that may not be quite so effective, where the waves basically will wash the oil out of the boom if we're not careful. So it does work on certain shoreline types, and something that we can consider. Mechanical recovery, so advantages, obviously removes large amounts of oily waste, oil and oil sediment in quite a short period of time. Equipment is readily available in this case, because most countries you go to, you'll be able to get your hands on diggers or machinery, plant machinery to do this. And you only need a small workforce. You don't need as many people if you've got big machines doing the job. Obviously, there are some disadvantages. Does require good access points, so there's a lot of shorelines. This won't be practical, so you won't be able to get machinery on the shoreline. Can generate large volumes of waste. Machinery, as you can imagine, is less selective than people, so you might end up, when you're trying to recover the oil, picking up quite a lot of substrate with it, so you end up with a lot more oily waste. Potentially could have more of an environmental impact, so it's something that needs to be very carefully managed. What you don't want is machinery driving over an oiled shoreline, pushing the oil further into the sediment. Or driving off an old shoreline and taking contamination further down the road or into the local residence area, things like that, for instance. And you can only use it on a few shoreline types, really. It's got to be quite a flat shoreline type, like a sandy beach or maybe a gravel beach. As I already mentioned, manual recovery is one that you're probably most likely to use, either in conjunction with the others or maybe on its own in many cases. Great advantages: can be more selective, so you can just concentrate on picking up the oil and leaving behind the substrate, so you're not creating more waste. You don't have to be a specialist to be able to work at a shoreline recovering oil. You need supervision and some basic training by specialists, so you'll need some sort of trained responders to supervise people. I've been on to several spills where we've used local labour workforces, and we've given them basic training at the time, given them some basic safety training as well, and then they've done a perfectly good job of cleaning up that shoreline. And can be used in a wide variety of shoreline types. Obviously, people can get access to certain areas that machinery can't, for instance, so you can get people into areas that and be more environmentally sensitive with those people as well. You might need a large workforce, and with a large workforce becomes all the logistics. So you might need to provide transport to and from site. You might need to provide accommodation for them if they're coming from out of area. You might need to feed them, and obviously feed and water them. Safety, you have to look after their safety while they're there. So that might mean setting up field station, first aid stations, having evacuation points, things like that. There's quite a lot of logistics involved with having a large workforce on a shoreline to keep that workforce safe. Manual handling could be a concern on the shoreline. Obviously, you can imagine quite a lot of manual handling cleaning up the shoreline. So making sure that they're doing it safely and have been given some basic manual handling training is quite key. And you've got that duty of care towards those people as well. You don't want to put them in a situation where they're going to put themselves in harm's way. They may not be aware they're doing that, so that's why you do need those trained supervisors who are going to keep them safe, basically. With all of those different techniques, and I should have probably mentioned this a little bit earlier, you would be carrying out your NEBA. Part of the survey piece would be carrying out NEBA, seeing what you can do, what would be effective for that particular environment that you're cleaning up. So it's important that we don't just go in there and start doing these things without carrying out that survey beforehand to make sure it is the most suitable response technique for that shoreline. And we're not going to make the situation worse by carrying out any of those techniques. So stage 2, so we've got rid of our gross contamination. So anything to remobilize, we've basically now removed, and now we're looking at picking up what's left. So any staining, anything that's absorbed into a shoreline or stuck to the rocks or is in the mangroves and isn't moving easily. This is basically the phase that we're gonna talk about removing that contamination. So this is the phase that can take a long time for on a shoreline cleanup. This can take days, weeks, and in some cases even months for this phase to be completed if you've got a major impact. So one thing we can do is high volume, low pressure flushing. So this is quite a flexible tool, if you like. We can use this on lots of different shorelines. And what we're doing basically is flushing large volumes of water, getting that above the level of the oiling, if you like, on the shoreline, flushing large volumes of water across it. That will lift the oil out off the top of the substrate and out from within the substrate in certain circumstances. You flush it back into the water, where you've got booms out in the background and then skimmers to recover the oil from the water. That way you're not removing lots of substrate. You're removing the oil, put it into the water column, into the water where it can be the skimmer, and you get a high oil to water ratio for your waste removal. Can take quite a long time depending on the shoreline type, but it's quite an effective cleanup technique, and can be used on varying shoreline types. You can use it on a gravel beach, as you see here. You can use it on a sandy beach. You can use it on some rocky shorelines, depending on the situation. You can potentially use it on salt marsh and mangroves, as long as you can get basically behind those areas. You don't want to start dragging lots of equipment and tools through the middle of the salt marsh or a mangrove, because actually that could cause more damage. So again, it's all about understanding your shoreline type and what you can and can't achieve without making the situation worse. So in some cases, you could use this in salt marsh and mangroves. One key thing to remember here is that if you're using high volume, low pressure flushing, to make sure that you use salt water from the local environment. You wouldn't want to do this, for instance, by bringing truckloads of fresh water in, because many of the organisms and species that live in that particular shoreline are saltwater creatures. If you start flushing lots of fresh water across that area, you could actually do more environmental damage than good. So using salt water from a local environment is a key thing. Just high loads of volume and flush it back into the water, where it can be removed by skimmers. As an example, that was Exxon Valdez. That's we can see there. They've got a hose across the back there where they've got lots of water being flushed out. That's them running down the shoreline. You can just see in the distance over by the helicopter. Not sure what's down there, but over by the helicopter, there's some boom in the water, and then there'll be a skimmer down there somewhere removing the oil from the surface of the water. So that's Exxon Valdez. There's also a gentleman in the middle there with the yellow trousers, yellow waterproof trousers on. He's got a hose in his hand, and he's sort of enhancing that by using that water to mobilize the oil as well. So that's a higher volume, low pressure flushing. Something else we can do, and that works on the high volume, low pressure flushing works on the surface, but you can actually use it subsurface to a certain degree as well, where you can get a lance. And if you know that the oil has penetrated to a certain depth, if you can push the lance in below that depth, as the oil bubbles to the as the water bubbles to the surface, if you like, it will pick up the oil on the way through, bring that to the surface, and then again it runs down the shoreline into the water, where you've got your booms out to contain it, and you can use your skimmers to remove it from the water surface. So that's just another variation of that low pressure flushing, really. You'll have noticed that I've constantly mentioned low pressure flushing there. What you wouldn't want to do on many of these shoreline types is high pressure washing, because by high pressure washing, what you'll be doing is sterilizing the area, and we'll talk a little bit more about that later on. So low pressure, so you're not taking away a lot of the organisms and species that are living there as well. Another technique might be surf washing. Again, I've mentioned NEBA already, but I'm going to mention it again, making sure that what you're doing isn't making the situation worse. But in some cases, what you can do is remove the substrate that's lightly contaminated, put it into the surf zone somewhere else where there's a high tidal sort of action and lots of surf zone activity, and allow nature to allow that surf zone then to clean the sand. So in this case, they've deposited the oil substrate on the shoreline there. They would come along next with bulldozers and diggers, push that into the surf zone, and over the next few days, as the tide comes in and goes out, and the surf rolls over it, it will basically break that oil up, bring out the oil out of the substrate, and break it down to such small molecules in the water column that it can basically becomes a food source for whatever lives in that environment. And that is an acceptable way of a shoreline cleanup. Again, as long as part of your survey shows that is environmentally. What you don't want to do is move too much substrate where you change the shoreline profile, and that could have a knock-on environmental effect. So being aware of that before you make the decision to do this is something that needs to be considered. So in this particular case, they put the substrate there, they will push that into the surf zone, and then this is the same shoreline 3 weeks later, and you can see that there's minimal oil left there now, and that shoreline's redeposited the sand back on the beach and removed much of that oil. Another thing we can do, which is actually, I'll just go back actually, what is similar to that, rather than doing surf washing, we can actually temporarily remove, in some cases, again, if it's suitable to do it, we can temporarily remove substrate and take it away and basically wash it. So we can take away sand or gravel or boulders, and we can or cobbles, and we can put them into things like concrete mixers with high volumes of water, roll them around inside those sort of situations for a while. That will clean off the substrate. You can then put the substrate back on the shoreline where you removed it from, and you've got then your oil and water as your waste product from that cleanup technique. So that's another variation of washing, if you like, the shoreline. So that's something else that we can use at a sort of stage 2 level. And stage 3 is where we're going to do our final treatment, and that's building up to and getting to our endpoint. And as I've mentioned about endpoints earlier, that doesn't necessarily mean the shoreline will be as clean as it was before the oil arrived, but it's the point at which you're going to be finishing that shoreline cleanup for that particular shoreline and letting nature take over the rest of the cleanup from that point, really. Different techniques we can use, again, as you can imagine, for different shoreline types. That final polish, so top right of the image there, you can see they are pressure washing. So on a man-made structure, anything that lives on a man-made structure has obviously grown, that structure was made. So that may will probably come back again once you've done some sort of quite aggressive cleaning. So you can be quite aggressive on a man-made structure, hence they're doing high pressure washing. You wouldn't do high pressure washing on many other situations. Bottom left, you've got a beach grader basically, and that might be something you could use if you're a sandy beach and it's been deemed that that's a suitable way of removing any of the final tar balls or things like that that might be in the top 2 or 3 inches of the sand. You can use that sort of machinery for that final polishing. And again, more often than not, you'll actually have people on the shoreline manually individually to the point that they reach the endpoint that's been required. So what we're trying to avoid is that over sterilizing. So by setting that endpoint and making that a realistic endpoint, that's the point at which we clean to. If we go beyond the endpoint and we over clean, then that's when we're going to cause more environmental damage if we're not careful. So a good example of that was the Sea Empress spill in the UK back in 1996. They deliberately, there was quite a rocky shoreline. They deliberately chose a particular part of that shoreline, a particular sort of cliff face, if you like, where they high pressure washed a section of it. So high pressure steam cleaned a section of it, and the section next to it they low pressure flushed. As you can imagine, at the time of the response, that piece that the high pressure wash was very clean and looked like it had been dealt with effectively. And the pit that the low pressure flushed still had some oil staining and some residue of oil on there. And that's how it was left. When I joined OSRL in 2008, part of our training would go back and do field studies in that particular area where that spill was. And one of the things we looked at was that rock face. And you could see, even that was 12 years later, you could see that the area that had been low pressure flushed and then left to recover had recovered far better, because all the organisms and the species that were living under the oil basically were still there. And had a chance to recover. That area had recovered far better than the area that had been high pressure steam cleaned, because that had been sterilized, everything had been removed. They were starting to come back, but it hadn't recovered as well as the area that had been low pressure flushed. So that's an example of what you can do with over cleaning, over sterilizing. You can actually make the situation worse. So that's why it's important to set those endpoints and work to an endpoint rather than to the point at which it looks as clean as it was before the oil got there in some cases. Some other shoreline considerations. I'll start at the bottom here. Actually, safety is obviously our #1 priority. We want to make sure our responders and members of the public are all kept safe. So making sure that our responders are trained, have been supervised by trained people, and are given the right safety awareness and equipment to keep themselves safe is the #1 priority. If it's not safe to respond to a shoreline, then we're not going to respond to that shoreline. There are some cases where it's a safety call to not respond to certain shoreline types, and that might be because the shoreline type itself is dangerous. So it might be a particularly high energy exposed rocky shore that's got difficult access and egress. So we decide actually we'll let nature take over on that one, and we'll not put our people in danger. Or it might be for other reasons. It might be as a response that we went to at one stage where there was a danger of tiger attacks on the shoreline. So we didn't do a shoreline response to that particular shoreline, or that piece of shoreline, certainly. So there's other considerations, but safety is obviously our #1 priority about people, and then environment is a close second. If you have got a shoreline response going on and you have got lots of people, then you're going to have to provide them with PPE. And as I already mentioned, some shoreline responses may take days, weeks, or even months. And that can be, if you've got a large amount of people, a lot of PPE. So that logistics of finding that and purchasing it, and supplying it to your responders can be a little bit of a bottleneck. So that's something that needs to be thought about early on in a response. Transport, so transport of people. We've already talked about how many people there might be, but also equipment and waste. All these different shoreline cleanups, most of them are going to involve some sort of equipment, whether it just be hand tools or whether it be booms and skimmers or even large plant machinery. That's going to need to transport to and from site. So having a transport sort of plan in place quite early on is a key consideration. We haven't really touched on it too much, but waste, the amount of waste that can be generated from a shoreline response can't be underestimated. Even a relatively small oil spill can potentially generate quite a lot of waste, whether it be oil sediment, oil debris in the shoreline, the oil itself, the oily water that's recovered. It could be old wildlife. It could be the PPE that's been used by the responders. If they've been there for some time, then food packaging that the responders are receiving their food and things like that. There are lots of things that become waste during a shoreline response, and it's quite a large. It potentially can be a very large volume of waste that you then need to deal with as well. So having a waste management sort of plan in place as early as you possibly can during response is a key action. Even before you have a shoreline impact, you should be looking at how your waste management plan might pan out and where you're going to dispose of all the different types of waste that you might get and where you're going to dispose of them as well. And then site setup, hot, warm and cold zone. So again, having those trained supervisors on the shoreline, not necessarily all trained responders, but all trained supervisors on the shoreline. One of the things they'll be looking at will be setting up their shoreline zoning, if you like. The hot zone is where the oil is, and your responders will be when they're working with the oil, and the equipment that's in the been used that's getting oiled is in the hot zone. Cold zone is where everything is clean, basically. So you can have things like catering facilities there potentially, first aid stations maybe, equipment laid down for clean equipment will be in the cold area. And then the warm zone is the area that, as people are leaving the hot zone, they go through to get decontaminated. So as your responders are coming off the shoreline with their oiled PPE and their oil tools, they go into the warm zone. All their oiled PPE is either cleaned or removed from them, and their oil tools are taken away and cleaned or put to one side somewhere. So when those responders come into the cold zone, then they're essentially clean. That way they don't carry any contamination back to their accommodation or into any vehicles or into the food hall where they're going to go eating their food. There's no sort of further spread of that contamination, and they're not putting their health and safety at risk. And it's the same for equipment that comes out of off the shoreline, goes through the warm zone, is decontaminated before it relieves the site and goes into the cold zone, where it might get put down for use later, or it might get taken away to a different shoreline site somewhere. So equipment laydown areas as well. If you have got large amounts of equipment, you're going to need somewhere to keep that equipment. And if you've got equipment, you need to put some sort of security in place for it. All spill response equipment is quite expensive. It's quite what's the word? Attractive, I guess it is. It's quite dual purpose. There's lots of pumps and power packs that can be used for other purposes. So they are quite attractive. So putting some sort of security in place is also something that may need to be considered. And we already talked about the manpower piece. So providing rest facilities, all the other logistics that come with looking after manpower is something that needs to be considered as well on a shoreline response. Just in summary then, every response is different. Oiling levels will differ, oil types will differ, shoreline types will differ, seasonal variations. So the same type of spill and the same shoreline, but a different time of year, will have different environmental sensitivities, and we'll may well even have different cleanup techniques as well. So no two spills are ever the same, so they all need to be treated as a new spill, if you like, at each time. They do need that proper preparation with the SCAT piece that Stefan mentioned earlier, making sure that the surveys are carried out before your response teams get there. And the shoreline piece is actually more of a project management. The whole piece is more of a project management than it is for an emergency response. At sea, we need to respond quite quickly and do as much as we can at sea. Once it is the shoreline, we need to make sure we respond effectively, but we don't respond in such a way we make the situation worse. So that means we've got to take a little bit more time with our planning and preparation and then delivering the response as well. So every response is different. Very important to use NEBA from the outset, so the net sort of benefit. People are our number one priority, but close behind that is the environment. We're trying to get that environment back to as good a health standard as we possibly can. So carrying out that NEBA assessment is quite crucial. And then in some cases, shorelines may not be as clean as the public/media might like when an endpoint is met. So that endpoint, as I already mentioned, is quite a key thing. It's a point at which we're going to leave a shoreline for nature to take over. In some cases, that might mean leaving oil stain there, or it may not look as clean as it was before the oil arrived. But that actually is still the most sensible point at which we're going to leave and let nature take over. Just a few if you're still interested, and hopefully you are, there's some good publications out there. IPICA and ITOPF, two industry organisations that do some really good work in the background. They've both got publications on shoreline cleanup and shoreline cleanup assessment technique and things like that. OSRL, we've got some publications on our website. Please feel free to access those and use those. And there's lots of other sites and other places as well that you can get more information about the shoreline cleanup piece. Thanks for listening. It was a bit of an overview. I haven't gone into a great amount of detail for any of that, so hopefully that's been interesting. If you do have any questions, feel free to fire them into the chat, and I will try and answer them before the end of this webinar. If not, we will get back to you later with the answers. And then after this webinar, if you've got any questions, feel free to get in touch with me, kenchurch@allspillresponse.com, or look on our website for more information as well. Thank you very much, and over to you, Chloe.
Thank you very much, Ken, for this very good presentation. It's now time for Dr. Annabelle Nicolas-Kopek to wrap up today's topic with a case study illustrating the various cleaning techniques. While Annabelle is setting up, I was going to say that don't hesitate, as Ken said, to raise questions. Those will be addressed at the end of the webinar during the Q&A session. And also I wanted to say hello to the GI WACAF focal points who are attending all our webinars from the very beginning of this webinar series. I've seen representatives from Nigeria, Liberia, and other GI WACAF countries, so it's a pleasure to have you today. Thank you, and the floor is yours, Annabelle.
Thank you very much. Good afternoon, everyone. So I'm going to try to wrap up this seminar by illustrating the shoreline cleanup with a case study. And before I start, I would like to briefly introduce ITOPF for those of you that don't know us. So over the last 52 years, we have been responding to spills and incidents from ships, providing spill response advice involving not only oil, but also HNS, dangerous cargo, cargo spill, and food product. We're a non-for-profit organization funded by the global shipping industry. Our technical team of 15 people, we're all scientists, so chemists like myself or marine biologists, for example, and we have responded over the years to more than 800 incidents worldwide. We are available 24 hours a day, 7 days a week, all year round, of course. And typically, in general, we're responding to around 20 incidents a year where we go on site. And we also have around 30 where we provide advice remotely. Right, so here's a quick summary of the incident that caused the shoreline pollution that I will be talking about. So you can see on this map the location of the collision that happened between a ro-ro ferry and a container ship off the coast of Corsica in Mediterranean. You can see Corsica at the bottom of the map here. You can see on the top left picture the two boats that are kind of almost embedded into each other. The ferry, the white vessel on the right, did not suffer any damage to his fuel oil bunkers, but unfortunately, out of almost 700 cube of MFO380, which is heavy fuel oil, on board the container ship, it was estimated that about 550 cube were lost at sea as a result of this collision. So in the previous webinar, the number 4, I talk about the action taken by the French and Italian authorities to collect the oil at sea. However, typically, as you may know, cleanup at sea can only recover a small portion of oil, typically 15–20%. And consequently, it's quite inevitable to have a subsequent shoreline cleanup. And 9 days after that collision, first arrival of oil was spotted on the French shoreline in the Var region. So on the map, it's on the right. And then subsequently, over the days and the week, the pollution extended to the whole French Mediterranean basin, up really to the Spanish border, contaminating more than 370 kilometers of shoreline, but quite in an unequal way, with moderate to heavy contamination on around 20 kilometers of shoreline in the Var, and then on the other department, it was more minimal pollution, but still requiring some cleanup operation. Now, due to time constraint, I will only concentrate on this presentation on the shoreline cleanup done in the Var, so the most contaminated area. And for those of you who are not familiar with this French region, the Var typically welcome more than 9 million tourists. That's data from 2012. And that represents almost 6 billion euro in French economy. So it's quite subsequent. The Gulf of Saint-Tropez is part of the French Riviera, attract more than 1.6 tourists a year, with the majority of this during the summer. Now on top, right, you can see the beach of Pamplonne with its 4 kilometers of sandy beach. And you can see at anchor some of the mega yacht. So the pollution reached the shore at the end of October, which is at the end of the tourist season. But nevertheless, you can imagine the pressure received from the authority to complete the cleanup as soon as possible. So here's the comparison of the beach of Pamplonne. On the left, the typical photo in summer. Against the second picture showing, and the third showing the first arrival of oil in taken aerial view and from the beach. So something to mention, in the second picture, you see a lot of black spot on the high water mark. That's not oil, or not only, but mainly Posidonia, which is an aquatic plant endemic to the Mediterranean basin and a protected species. There are two very different types of habitat impacted by the pollution, some natural and some urbanized. On this very touristic coast, some parts obviously were very urbanized, but also in quite rarely for France, some coast access were really restricted due to large properties or construction right at the edge of the sea. So you can see the picture on the bottom right, really close construction. We also had some very wild natural areas where it was easier with access, but still could have some challenge. And I will go back to those challenges in a little bit. Now, it's worth to note that the weather condition when the oil reaches the shoreline play quite an important role on the type of contamination that can be observed. So in our case, on the day of the first landing, the weather conditions were quite stormy. We had very rough sea and a storm surge, which generated the contamination very high on the beach. And the projection on cliff or rocky wall of oil Posidonia were like several meter high, and I was splashed by the force of the waves. So here's a summary of the different type of substrate that were impacted. So the beaches with starball and patties, but also oil debris, oily wood, oil Posidonia, buried oil as well. And on the rocky shore, we had some oil pool, projection of cliff. So quite a wide variety of substrate. And I think you have seen in the last two presentations that would dictate very different cleaning technique to adopt. In terms of the organization of the cleanup, the French system is such that the emergency phase is managed by the state. In addition, the plan Paul Marter was activated, which mobilized certain state resources, such as the civil protection, fire brigade, and local authority agent. And the control and the coordination of the operation stay with the prefecture. The prefecture was advised by SEM, some of you know them, as technical experts, and ITOPF, of course. The priority of that phase was really the removal of any mobile oil from easily accessible areas, such as the Pamplonne beach, but also some other communal beaches. Each town provided workers cleaning on their own shoreline, but there was not really a coordination at the departmental level. So as a result, the deployment of the task force was not really done according to the extent of contamination, and so it could have been done in a more efficient way. For example, you had some people collecting small tarball in one town, while the next town still had some mobile oil present. This phase also set up the first temporary waste storage areas and set up decontamination areas, and this was done with a lot of rigor. However, the segregation of waste was quite insufficient, with very large quantities of unoiled wood and sediment collected, necessitating later to be reprocessed by a private company. Very quickly, the French state asked the ship owner to take over the response, and that's quite typical for the French system. And therefore, the company Le Floc Dépollution was immediately mandated by the insurer on behalf of the ship owner. Le Floc therefore took over the state team from Paul Marter under our supervision, and of course in consultation with the authorities. During the transition phase that lasted around 10 days, we saw that the private means increased while the state assets slowly got demobilized. All in all, we had around 150 people per day that were employed for between October and April. That was the length really of the cleanup operation, so roughly 6 months. In addition to a team monitoring any new arrival of tarball during the tourist season in the summer. So in total, roughly 19,000 person day were necessary, and the cost of this cleanup was entirely paid by the ship owner via the insurer. So as for ITOPF, our role was we acted as technical advisor to the insurers, but also to the authorities. In this capacity, we remained on site from the beginning to the end of the cleanup for 6 months in a rotation. And in collaboration with Le Floc and CEDRE, and of course the authorities, we established cleanup strategies, taking into account local requirements, as well as setting up opening and closing of cleaning sites. We provided technical support to the claimant and make the technical assessment of the claim received by the insurers. So the first priority of Le Floc after the transition period was, again, the recovery of mobile oil to prevent, or at least to limit, the secondary contamination. And Le Floc used local labor, like Ken was mentioning before, instead of volunteers, which had to be trained and supervised for increasingly complex cleanup operations. I don't really have time to go into the issue of the integration of volunteers in cleanup operation, but that's something we can discuss later should you wish. The other important aspect was the segregation of the debris, so either wood or Posidonia. So the clean or slightly contaminated wood were left on the high water mark of the beaches, and that the middle picture at the bottom. And then sometimes brush to remove small oil accumulation. On the other hand, for oil wood, as shown at the picture on the top right, that obviously was removed and treated as waste. So I'm going to present to you now, but quite quickly, because it has been discussed in the two previous talks, the 5 main type of substrate that we encountered in this response. So first of all was the collection of tar balls and patty at the surface of sandy beaches. And this was done, as you can see on the picture, from left to right. First by manual collection with quite high care to segregate, to limit the waste. Then big bags that were left and filled on the beach were collected by excavators and then taken to secondary storage area. Then there was a problem of buried oil, and I saw a question from Malaysia about that in the comment. And that was due to the very dynamic shoreline. Without cleanup, these areas are a constant source of secondary contamination, as they will release tar balls depending on the weather conditions. So after surveying the beaches for buried oil, the second picture on the top, the contaminated area was excavated and oil was manually collected. In some area, and that's the 2 pictures at the bottom, we use the lens, the flushing, as you can see from the picture below, followed by manual recovery as well. On rocky shore, the cleanup was done again in a very classical way, with first by removing any accumulation, scrapping those accumulation off, and then we have a combination of flushing and high pressure. And you can see as well the photo in the photo the use of geotextile to protect some cleaner area from oil splashes during the cleaning. As you have seen in the previous Ken presentation, the cleaning of pebble can be quite complex and quite time-consuming, really. Again, in our case, this follows a typical cleaning process with manual collection and sorting the most contaminated pebble out, followed by the removal of accumulation by scrapping or brushing, and then using a combination of flushing and high-pressure washer, and sometimes the use of cement mixer to clean more mechanically those pebbles. Finally, we had the cliff or rocky walls that were cleaned again with scrapping and then high pressure. On the picture on the top left, you see the picture before, then bottom left during the cleanup, and then on the right, the result from the cleaning. You can see on the picture on the right as well that if you have good eyes, I'm sorry, but some equipment are placed a bit in the middle of nowhere, or at least there is no evidence of road or pedestrian access. And that was quite a recurring or quite a typical cleaning site for us in this incident. Here is another example of a similar place. The picture on the right shows the degree of contamination, and of course, it's clear that it needs to be cleaned. However, there is no evident access to this area. Those access were limited to either, in this particular case, 15-minute walk along a coastal path, or an access by a private resident, a lock gate, and then the path was then quite steep and narrow. So bringing equipment and staff safely was therefore quite a challenge. So in order to overcome these difficulties, a helicopter was used to bring certain equipment on site, but also to remove the waste from the most difficult area to access. For areas that are a bit more accessible by sea, a boat was used as well to bring equipment and as well to be used as a working platform. However, this means that you are quite dependent of weather and sea state. And therefore, it's more difficult to predict when really you can use this asset. As Ken highlighted in his presentation, the main priority is, of course, maintaining the health and safety of the public, of course, but also the workers. And this poor access can endanger the health and safety of the workers, and that remains the top priority. So on the right, you can see that some handrails were installed to make sure that the worker could come down on the sites safely. Also on the cleaning sites, you need to think about adequate protections. Again, the wind and the sun, and that's the picture at the bottom, and as well bringing toilets and rest area. And all of that needed to be brought on site. Some issues as well were due to some human activities. So if you look at the picture on the top left, that's a picture of syringes collected during the cleanup work on the beach of Pamplona, used by drug users, presumably during the summer. So each worker really had to follow the safety protocol, which were reminded to them daily during the daily briefings. As for the public, there were closure of beaches and public paths where cleaning areas were done in order to guarantee the safety of both the public and workers. I will show you now two examples of before and after picture, because it's always quite impressive to see what cleanup can achieve. This is what has been done in 2 months of work in an area that was particularly impacted by accumulation of oil Posidonia on the left. And you can see how well now with the cleanup this area ended up being. And then similarly in this example that I have shown previously about this particularly complex site, due to the difficulty of access and the difficult type of substrate with cobble and pebble, you can see the result of the cleanup activities. In terms of waste and the cumulative total of waste collected by the private company, Le Floc, was around 580 cubes of waste, and that included 52 cubes of oily sand and sediment, which is quite low, and show really the how efficient segregation and manual collection can be, and why it's important to use when possible in situ techniques. And then these waste were then treated through different waste streams. You may have noticed though that a large portion of this waste was made of oil, wood, and oil Posidonia, which accounted around 60% of the total volume of waste. In the picture on the left, you can see the beaches before the pollution, where you can see the large volume of wood stranded on the beaches is quite typical at this time of year for the shoreline. Now, if that is oiled, a picture on the right, then logistic for the removal, the transport of this waste must be put in place, and time must be spent to segregate it. So, as it was mentioned before, there are activities that can be carried out ahead of a pollution incident to limit that waste volume, and clearly in this case that was not hasn't been done. One of the reasons was the minimization of the quantity of oil remaining at sea by the Maritime Prefecture during the at-sea response. So in a press release a few days before the first arrival of oil on the shoreline, the official figure was around 2% of the volume spill remained at sea, which correspond to less than 10 tons of oil. So this has generated quite, has generated a certain amount of expectation from the municipalities and certainly like a lack of preparedness for a more significant arrival. So, however, it's quite interesting to note that some municipalities, seeing the amount of oil arriving on the shore in the Gulf of Saint-Tropez in the first few days, had time to take pre-cleaning measures and remove a vast quantities of wood and Posidonia off the shoreline and put them really high on the beaches, which limited the volume of waste considerably and also speed up the cleaning process in their shoreline. And it's worth noting as well that these measures of preventive measures were fully reimbursed by the ship's insurance. And finally, and as I spoke with about compensation, I spoke throughout the presentation about some costs that were brought by the insurer, but obviously I don't have time to go too much into the detail. But the insurer opened a claim office, so it's a local office that will receive and process claim and aim to guide claimants in that process. This was done through the preparation with ITOPF of standard forms and official notices displayed in the press. I would say that the opening of the CSO is quite typical for moderate to major pollution incident, or at least when you will expect a significant amount of claim. Claims typically are grouped into 5 main categories, and I'm not going to go through each of those, but obviously you have property damage, cleanup and preventive measure I talk about, measure to prevent economic loss, so for example, funding of campaign to limit economic impact on tourism, environmental damage, so that will include funding of post-spill monitoring studies, and an important one in our case is the economic loss, so claim for compensation for damage to image and tourism, for example, but we also had few claims on the catering sector and, of course, fishing sector. All those claims were covered by the 2001 Bunkers Convention, to which France is a signatory state. And finally, to wrap up this talk, I wanted to highlight a few points about this case study. In terms of priorities of site, and that goes with Ken's presentation, the importance of cleanup priorities, with quite a difficult balance to have between environmentally sensitive sites and other sensitive sites, but more from an economic and social point of view. And in that regard, any preparation work, particularly during updating the National Contingency Plan, that really helped to make those decisions. It could be quite valuable to use a private cleanup company, particularly for long-term cleanup operation, but also to maintain a continuous dialogue with the authorities in order to facilitate agreement on cleanup strategy and signing off some sites, so the site closures. And finally, communication throughout the cleanup and a really early cooperation with the insurer does facilitate the handling and the compensation process. That's it for me. I hope I've been clear, and I'm more than happy to answer to any question you may have. Thank you.
Thank you very much, Annabelle, for this case study that perfectly illustrates what our previous speakers have said. With that, we'll now move to the Q&A session. We're already a bit out of time, so I'll pick a few questions. The first one is from Paul Humphries, who is actually one of the GI WACAF steering committee members. So hi, Paul. The question is directed to Ken and is the following. Ken, can you provide examples on how you would look to establish shoreline cleanup teams in a West Central Africa context? strategies to engage with affected communities who will no doubt want to become involved in cleanup?
Yeah, well, local communities are quite often, they're obviously keen to get to volunteer and to be involved with their own shorelines if they are stakeholders, and they will know their shorelines better than we would, coming from other countries, if you like. So getting involved with local stakeholders, local communities is quite a key thing, and they are best placed to provide that shoreline cleanup. So we would be looking to make contact with those communities, either by depends who mobilises a little bit really, but either through the mobilising party for OSRL, for instance. So if we mobilise by an oil company, we'll be looking at them to source those resources. Quite often they will already have contacts in the country. So if they're established and working in that environment already, they will have contacts with the local community already. So that might be a way of doing it. Or potentially through local government as well. If we're coming into an area where we haven't got that contact, we could maybe approach local government and get them to put us in contact with those local communities. And then if it's suitable, we'll put supervisors in that area to be able to use that local community for that shoreline piece. They are quite often well placed and best placed to provide that shoreline cleanup assistance, certainly.
Mm-hmm.
And Chloe, just to add, I mean, we would do the same thing for SCAT team members. We would probably establish like community liaison just to identify people that could join us in the field and train them as well at the same time.
Okay, great. Moving on to the next question, which is for you actually, Stefan. How is the economic value of the cost factored into prioritizing the cleaning process? I know that Ken already gave a part of the answer, but it was in private to the person who asked. So can you tell everyone, Stefan?
Yeah, I mean, the socioeconomic value is one of the key components that the information that the people would collect in the field. I mean, part of the SCAT teams. And I think Annabelle provided a very good example with her case study of a beach, for example, for tourism. Obviously, how the beach is used is an important information to prioritize. And she showed, I think the spill happened in October and the tourist season was like in June, July. So if the spill happened in May, for example, just a few weeks before the tourist season, obviously the ranking of that specific area in terms of priority would have been much higher than maybe it was. So it's this way that we're looking at the things, how the shoreline is used, and it's not an economic value per se, but it's more like how the beach is used and to make sure that we clean up to restore usage as much as possible and in the right time frame as much as possible.
Ken, would you like to add something?
That pretty much covers it. Part of that pre-survey is not just, I talked a lot about the environmental piece, but it's not just the environmental piece. As Stefan mentioned, it's a socio-economic piece as well. That survey is all fed back into the incident management team, wherever they may be, and they're going to prioritise their site for protection and also their sites for cleanup as well, based on all of that information. It's not just the environmental, it's socio-economic as well. So that will feed into it, certainly, yeah.
All right. Then Annabelle, the next question is for you. So in your case study on the shoreline aspects of things, what could have been done better during the shoreline response operations you discussed?
Yeah, that's always interesting to look at lesson learned. I hope I have answered part of it when I addressed at least the emergency phase with the government, and so I'm not going to go back to that and the issue mainly with segregation and prioritization. But I think overall the main difficulties that is often solved with a good cooperation with the authorities is the prioritization of the site, because obviously all the local authority want their site cleaned up as soon as possible, and so that is where the most friction or the most tension can occur. And in our case, some sites if you look at on paper, had to be cleaned before other sites due to some political pressure, but not really in terms of environmental consideration, but that's also part of that's part as well of the cleanup. You have to take into consideration several factors, and yeah, that sometimes high has to be.
Thank you very much. One last question, perhaps. I don't know who wants to answer this one. What are the main challenges at 21st century when dealing with cleanup the oil spill? What are the best technologies available at the moment?
If I talk quickly about shoreline evaluation, I think social media is a big challenge. I mean, anybody can go on a beach and take a photo out of context, just showing a large pool of oil, and maybe in reality it's just a very small section of a beach, and then everything is blown up into proportion. So that's why we need teams in the field that provide the real information. So that's a challenge now, because I think the Mauritius spill, the recent Mauritius spill, might be a good example of that. I mean, we've seen loads of photos on social media, and it was not really a reality. And technology for evaluation, I mean, obviously data collection tools are more efficient and more, and drones as well, like remote detection of oil on shoreline. I mean, there's new technologies, sensors and stuff like that. So that's going to be helpful in the future.
Definitely.
Yeah, I can only bounce back on Stefan. I think the impact of media, I think, shouldn't be underestimated, particularly how that may impact decision and the pressure that may have on the command center, not only in the logistical but also the operational, and the impact in compensation as well available. So that has a huge impact nowadays, and the amount of data that people are able to have, but not really information. So like raw data, but not combined with proper analyzed information. Yeah.
Thank you. Well, unfortunately, we came to the very end of the webinar, so we'll make sure that Q&As are available on the GI WACAF website in a few days from now. So this was the very last webinar of this first GI WACAF webinar series, but we will meet again next year for other topics to be covered by our experts. I warmly thank our speakers today for their involvement in this webinar and their very high quality presentations and answers. I also thank my colleague Julien, who worked with me on the organization of this webinar. And finally, thank you everyone for attending this webinar and engaging with us. We received a lot of highly interesting questions. So we'll answer soon. I'll leave it here, and I wish you all a happy holiday season. Very nice end of the year. Thank you very much. Goodbye.
Thank you.